NASA gravity waves are responsible for Jupiter's jet stream flip-flops. Jupiter is a very different planet than Earth, but scientists at NASA's Goddard Space Flight Center think they've unraveled a mystery on the solar system's largest planet that could affect how we understand the weather patterns here. For decades, scientists have puzzled over an atmospheric jet stream on Jupiter called the quasi-quadrennial oscillation, QQO, that reverses direction roughly every 4 Earth years. A new model developed at Goddard points to gravity waves in Jupiter's atmosphere as the cause, and we might have a similar mechanism on Earth. We don't have the QQO here on Earth, but we have a smaller version called the quasi-biennial oscillation, QBO. The QBO describes air currents between the lower stratosphere and the edge of the troposphere, where we live. Every 28 months or so, these currents flip direction between eastward and westward. Jupiter is much larger than Earth, and it rotates faster. However, fluid dynamics should operate the same everywhere in the universe, and that makes the larger atmospheric patterns on Jupiter a potentially good test bed to understand what's happening on Earth. On Jupiter, the QQO covers a massive swath of the planet, so NASA needed long-term observations covering a similarly large surface area to develop a model. Researchers used the Infrared Telescope Facility, IRTF, in Hawaii, which was equipped with a high-resolution instrument called the Texas Echelon Cross-Echelon Spectrograph, DEXIS. This allowed the team to collect atmospheric data from Jupiter for 5 years between 40 degrees north to 40 degrees south latitudes. The IRFT was able to probe deep vertical slices of Jupiter's atmosphere and return vastly clearer data. The team found that the QQO extended far into Jupiter's stratosphere. With data covering such a wide area of Jupiter's atmosphere, several types of atmospheric effects were ruled out as major contributors to the QQO. That left one main culprit: gravity waves. The model from Goddard uses gravity waves produced by convection lower in Jupiter's atmosphere to simulate QQO changes in the stratosphere. The model is reportedly a very good match for real-world observations. So, how does this relate to Earth and the QBO? Gravity waves have been considered as a driver of changes in this atmospheric pattern, and the results from Jupiter strengthen the case. Scientists suspect several other effects contribute to changes in the QBO, but this study gets us closer to the answer. It could also help us understand the atmospheres of other planets, even those